Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will explain to you how to write down the distribution of the sample proportion and how to use that to find out the confidence interval of the sample proportion. If you have a random variable x which follows a binomial distribution with n number of trials and p be the probability of success of each trial. So you must already know that the expectation of this binomial distribution is n times p and variance of this binomial distribution is n times p times q. So once you know the expectation and variance, the variable that we have to deal with is going to be sample proportion. So x if is the number of successes and n is the total number of trials, then the sample proportion is going to be x upon n. So we have to write down the distribution of sample proportion, which is actually x upon n. So to find out the expectation of sample proportion, we will use the fact that expectation of ax is equal to a times expectation of x. So if you have to find expectation of sample proportion, which is x upon n, the 1 over n comes out and that's going to be 1 over n times expectation of x. And we already know that expectation of x is n times p. So it becomes 1 over n times n into p and that will be p. So that means the sample proportion's expected value is equal to p. Likewise, if I want to find out the variance of sample proportion, I will recall the fact that variance of ax is equal to a square variance of x. So if I have to find variance of sample proportion, which is x over n, and if n constant comes out, it becomes 1 over n square variance of x. And variance of x is npq. So it becomes 1 over n square npq and 1 of the n cancels out and it becomes pq divided by n. So the first thing that you must understand is that if you're dealing with the variable which is sample proportion, then its expected value is going to be p and its variance is going to be pq upon n. And that is something that you have to learn to move on. So every time you write down the distribution of sample proportion, its expectation is going to be p and its variance is going to be pq divided by n. So once you do identify that, then for large sample size n, which is greater than 30, then sample proportion must be following a normal distribution. If sample proportion can be approximated as a normal distribution, its expectation comes out to be p and its variance comes out to be pq upon n. So once you have written down the distribution of the sample proportion, you can always use the confidence interval formula to find out the confidence interval of sample proportion. So you must know that if you have a variable x that follows a normal distribution with mu and variance sigma square, then its confidence interval is going to be mu plus minus z under root sigma square. So likewise over here, if you have to find out the confidence interval of the sample proportion, that's going to be mean, that's p plus minus z and then square root of variance. In this case, that's going to be pq upon n. So you can directly apply this formula and get yourself the confidence interval. So let's have a look at few examples over here. Like the question says, the manager of a video hire shop wishes to estimate the proportion of the videos damaged by the customers. So he takes a random sample of 120 videos and finds that 33 of them are damaged. So when he gives videos to the customers and when they return, he finds out that out of 120, 33 of them were damaged. So if for a sample, the proportion of damaged video is 33 over 120, then you can identify that the unbiased estimate of the population proportion is going to be equal to the sample proportion. So you can find out the unbiased estimate of the population proportion from that. And then you can write down the distribution of the sample proportion, which is going to be P, that is going to be 0.275, and then PQ upon N, that's 0.275. Q is 1 minus P. So it's going to be 1 minus 0.275 divided by N, that is going to be 120 in this case. So once you have write down the distribution of sample proportion, you can easily find out the 95% confidence interval. Again, recalling the fact that since you need a 95% confidence interval, then tails must add up to 5%. And each tail must be 2.5%. So if you subtract 2.5% from 1, then it's going to be 0.975. So you know that you have to calculate a z value of 0.975. So once you've calculated the z value of 0.975, and which is coming out to be 1.960, which you can read from the table, then you can directly apply the formula for the confidence interval. So mean in this case is going to be 0.275, z is going to be 1.960, and under root of variance. And once you solve these, you will get the end limits of the confidence interval of sample proportion. Guys, let's have a look at another example. So it says packets of cat foods are filled by a machine. In a random sample of 10 packets, the weights in grams of the packets were as follows. Find the unbiased estimate of the population mean and variance. You can use the sample to calculate its mean and its variance. Remember that the sample mean can be taken as the unbiased estimate of the population mean. But the sample variance is basically the biased estimate of the population variance. So you multiply it by n upon n minus 1, and it becomes the unbiased estimate of the population variance. Now, once you have the unbiased estimate of the population variance, these are going to be your two answers. Then in the next part, it says that a random sample of 200 packets, 38 were found to be underweight. So that means the proportions of underweight is going to be 38 upon 200 in the sample, and that can be used as the estimate of the population proportion. So your population proportion is going to be 38 upon 200, which is going to be 0.19. We need to find out a 96% confidence interval. We know that sample proportion follows a normal distribution with P and PQ upon N. So this is going to be expectation of the sample proportion, and this is going to be variance of the sample proportion. Since you need to find out a 96% confidence interval, each tail must be 2%. And that means that you have to find out a phi inverse of anything less than 2%, that's 0.98. So when you find out phi inverse of 0.98 using a z distribution table, that comes out to be 2.054, and then you can directly apply the formula of the confidence interval. That's going to be mean of the sample proportion plus minus z value under root of the variance, and you will get the endpoints of the confidence interval of the sample proportion. Guys, I hope it helped you to identify how to write down the distribution of the sample proportion and how to find out its confidence interval. I would really appreciate if you would like this video, post your suggestions in comments, and share. Thank you.